What's up, everyone? Welcome back. Patrick here, and moving on to the next question, the next knowledge question on the average rate of change test. So here we are told that a wave spreads out in a circular pattern, and this table over here shows the radius r in meters of the circular pattern during the first 8 seconds. And then we have a couple of questions here to solve. So part A, we have to find the average rate of change between 3 and 7 seconds. Then for part B, find the instantaneous rate of change at 6 seconds. Then part C, we have to talk about how the average rate of change and the instantaneous rate of change compare. So let's start off with part A. So we have the average rate of change between 3 and 7 seconds. So at 3 seconds, the radius is 12. And then at 7 seconds, the radius is 28, right? And if you remember, average rate of change is basically going to be the difference between the y values over the difference between the x values. Or in this case, it's basically r, the radius, at a time of 3. Or actually, let's do the larger time. So r of 7 minus r of 3 over 7 minus 3. Right, the difference between the independent variables, which are the t values in this case. So r of 7, what's the radius at a time of 7 over here? I don't know why I keep going up there. So it's 28 minus r of 3 is 12 over 7 minus 3, which is 4. So this would be 16 over 4, which would give us 4. And then be careful with your units. So the r is in meters, right? We're told it's in meters. And then the time is in seconds, so this would be meters per second. So that would be the answer for part A. The average rate of change between 3 and 7 seconds is 4 meters per second. Now moving on to part B, we have to find the instantaneous rate of change at 6 seconds. So we have to find the instantaneous rate of change over here. Now if you remember, when we're finding the instantaneous rate of change from a table of values, we're going to have to use the preceding and following interval method. You could also use the centered interval method, so you could find the instantaneous rate of change between the 5 seconds and the 7 seconds. However, I'm going to do the preceding and the following, right? So the preceding, so this is part B, the preceding interval is basically going to be, let's call it the preceding instantaneous rate of change. It's basically going to be between these two values, right? Right here. So it's going to be r of 6 minus r of 5 all over 6 minus 5. And r of 6 is 24. R of 5 is 20 over 1, which gives us 4 meters per second. So that's the preceding interval right there. And then I'm going to find the following interval, which is going to be between 6 and 7. So it's going to be r of 7 minus r of 6 over 7 minus 6. So r of 7 is what? 28 minus r of 6, which is 24, all over 7 minus 6, which is 1. Which is also going to give us 4. And then if you remember, our next step is we average these two, but I mean the average of the same amount is just going to be the same amount, right? So we're going to take 4 plus 4 divided by 2, which is going to give us our 4, right? So 4 meters per second, that's going to be the instantaneous rate of change. So I did it with the preceding and following interval method, and then once you get those, you just average them out. This average doesn't mean average rate of change. I'm just averaging out the preceding and following interval rates to get the approximation for the instantaneous rate of change. It doesn't give us the exact one, but it gives us an approximation. And so we get 4 meters per second. Now if you did the centered interval, right, so if you took it from 5 and 7, notice you would also get 4. So you would have 28 minus 20 over 7 minus 5, which would be 8 over 2, which would also give you 4. Now the centered method and the preceding following method, they don't always give you the same amounts, but in this particular case, they do give you the same amounts. And that's what they want us to talk about in part C. So how does the average rate of change and instantaneous rate of change compare? Well, notice that for both of these, we got 4 meters per second. And so why do we keep getting the 4 meters per second? Well, if you look at this table carefully, basically what's happening is it's a linear function, right? So if we were to graph this out quickly, right, so we would start at the origin, 1 and 4, 2 and 8, it would basically be a line that has a slope of 4. And so between any 2 points, the average rate of change, right, is going to be 4. In this particular case, we did it between 3 and 7, but between any points, it's going to be 4. And then the instantaneous rate of change, right, if we're drawing like a tangent at any single point, it's also going to be 4, right? So for any linear function, we've talked about this before, the average rate of change and the instantaneous rate of change, they are the same. And so that's what we want to say for part C. They are the same because it is a linear function. Right? So that's what they wanted you to notice in this particular question. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.